Today's topic is a simple one. This is, of course, an install topic, and that is things we want to keep out of our system and how we keep them out of the system, and some of the right terminologies for that. So let's just kind of go over them quickly. What are some of the things that you think are the worst to get inside of our copper tubing inside the system?
Water, dirt.
Water, dirt. What else?
Air.
What else? Water, dirt, air. That's a good list. Fire?
I feel like we were doing all the elements.
Okay. Earth, wind, and fire. Yeah.
Water.
Amazing songs. So, I don't know any Earth, Wind, and Fire songs off the top of my head. Otherwise, I'd sing one for you all. Yeah. You're glad. Yeah. Yeah. All right. What else? I know everybody always gets frustrated when I do this, but this is to make you think. Flush. That's good. Solvents. That's a good one. Yeah.
Copper shavings.
Copper shavings. That's one I was looking for. Very good. Keep copper in your copper. Keep your copper in your copper, and copper out of here. Right? Your compressor's just so excited. Nom 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 nom. It's like it's Copper Bay. There you go. Yeah. No nomming of your compressors. Yes, true. Anything else you can think of? We've got a good list there. I'm proud of you guys. But there is at least one other thing. We've got air. We got water, we got dirt, we got copper shavings, we've got solvent. Incorrect refrigerants, that's a good one. That wasn't what I was thinking, but that is a good one. Man, I thought you all were sleepy this morning. And there's one more though.
Inside or outside?
What?
Inside or outside?
Animal, mineral, or vegetable. It's all three. You want to keep animals, minerals, and vegetables out of the inside of the system. I mean, incorrect lubricants, so oils that don't belong in there, but the one that I'm looking for is nitrogen. Nitrogen. Now, again, when we say, do we want it out of the system? Well, we don't always want it out of the system.
No, we usually want it out of the system.
But we want it out of the system when the system's operating, when we've got refrigerant in there. So what are the two things we want inside the refrigerant circuit when it's operating? Yeah, that's it. Refrigerant and lubricant, right? Yeah. So POE is our typical oil lubricant that we use in most systems, but we also use PVE in a lot of our ductless systems. And both POE and PVE have this really kind of nasty trait of picking up water and not letting it go very easily. POE being a little worse in that it turns into this nasty acid. So we have to be very concerned about moisture in the system because of that reason, but the others also matter quite a bit. So what I see a lot of newer techs do, especially at Kalos, is because we focus a lot, at least I hope we still are, but I believe we are. We have pretty good processes. Like we make sure we pull deep vacuums. We've got a good system for it. It's not hard anymore to pull a good vacuum. And so we're getting most of the moisture out of the system on that front. We know you got to pressurize the nitrogen and all that, but let's actually let's start at the beginning with some of the most important things. So let's say you're going to a job and you're pushing copper. So you're running new copper. What's one of the most important things that you do when you push copper?
Seal the end.
Not kink it, seal the end, correct. So those are rubber plugs or plastic caps. Are those sufficient? No, why not?
Because they can pop off.
They can pop off, and they do pretty easily because when we're pushing that stuff through, it's pretty crappy. Folks who aren't from Florida have no idea what we're talking about because other people around the country don't push copper. They think it's nuts that we run copper underneath the ground. And actually, this is a good point because it really is kind of dumb, but it's just the way houses are built in Florida. And why is it dumb? Why is it dumb to run copper underground the way we do?
Because like the stuff in the soil that start to corrode the outside.
There's one reason. Soil can corrode the copper. That's one reason.
Well, another thing, it doesn't stay fully insulated, it rips and you can't see it in the
That's another reason. It doesn't stay fully insulated. It tears underground. A lot of times folks don't even insulate it when they run it.
Yeah.
You'll find that. Have you ever pulled copper out to find that it's insulated right on the ends, but then there's actually no insulation across the whole length of it?
Or it's all bunched right there.
Yeah, it's all bunched, yeah. And that actually makes a significant difference in the operation of a system. When you look at it's funny because we don't think about it a lot, but I did a podcast recently with Eugene Silberstein. He's the guy who wrote the RACT manual. And we were talking about pressure enthalpy charts. This is like goofy, kind of more advanced stuff. But when you plot on a pressure enthalpy chart and you actually start to account for the amount of heat that you can pick up in your suction line and the effect that that has on the performance of a system, it can be significant. Not just in terms of compressor overheating, but also just in system performance. So it's important that our suction lines are properly insulated. And so doofy stuff like that makes a big difference. But what are some other reasons why it's not really smart to run our lines underground the way we do in Florida?
Can't predict or really get a good idea of the condition of the chase.
It's another good one. Yeah, you can't see it. It's hidden under there. Heaven forbid we ever have a connection in the chase. I mean, that's something that we just never do, but it does happen sometimes, and it'll leak in the chase, which is terrible. Like we mentioned, corrosives in the chase. But there's another really big reason, and that is that we're creating a trap, right? So that suction line now has a big trap in it. And what carries the refrigerant or the oil back to the condenser? It's refrigerant, right? Now, POE oil, because it's more miscible, meaning it mixes better with the refrigerant, you don't get as much issues with oil trapping, but it still can occur. But the other thing is that when it runs through soil, and especially if it's cold outside or even in the mornings, we don't get this as much. In other places, the ground is very cold compared to the ground that we have here. So we have very sandy soil, very kind of loose soil. But that refrigerant oil is attracted to that liquid refrigerant, and the liquid refrigerant will condense in those low cold areas. And so for several reasons, that's bad. One is that we end up getting these oil seals in this, we lose oil down in those areas. But then also, when the system goes on, after it's been off for a while, you have all this liquid that's condensed, and that gets sucked right back to the compressor. And do compressors pump liquid? Not very well. Not very well. They're not designed for it, right? Actually, scroll compressors nowadays are a lot better at handling liquid than they once were because they can they're a little flexible in the head, and so it doesn't tend to destroy them as quickly, but it's not a good thing. So that kind of oil trapping, that holding liquid refrigerant, that trap function there is a really bad thing. Have you ever hooked up gauges to a system and had a bunch of oil come out?
Yep.
Ever seen that happen? That's one reason why that happens in our market more than others. But whenever you see that happen, I will bet you that you have an airflow problem. It's a weird little kind of side thing. This is a complete side note. It's not what I was intending to talk about, but since we're talking about it, because it is that refrigerant velocity that carries that oil back to the compressor. And so when you have low airflow on the inside, what happens to your suction pressure?
Drops.
Lower suction pressure, right? Lower airflow inside, lower suction pressure. Lower suction pressure means lower refrigerant velocity. That means that suction gas isn't coming back as quickly, and so it doesn't carry the oil as well. So it gets stuck there, and it ends up just being there kind of at the ports, kind of fills up that trap. But anyway, so it's not a great idea for us to be running copper underground anyway. But another reason why it's not a great idea is because when we're jamming that copper through the chase, it can easily break, and you can get sand or dirt or whatever in the lines. But what are some other ways that we can potentially get dirt in the system? Sand, dirt, solid contaminants.
Pack your stuff up when you're doing everything else.
Yeah. It's generally going to happen when you're just not being careful when you're doing that pipe work on the outside. That last little bit of pipe work.
On the inside.
You're bending, it could potentially, sure. When you're doing that final bit of bending, maybe you're adding some fittings or whatever you're doing to kind of make your final connections. If you're not careful and that stuff falls in the dirt, that end goes into the dirt, even when you're reaming or whatever you're doing. Yeah, right, yeah. Stick your finger in there and just pull it out real quick, yeah. And if you ever do get a case where you did drop something in the dirt, what is the procedure to follow at that point? Push nitrogen through the other side, yeah. With good solid velocity of nitrogen through the other side. If you're really in doubt, then use a pipe wiper or the New Hillmore line set cleaning tool. Push that through just to make sure. And that's why we do that. When we're reusing copper, we want to make sure that we're getting all that solid contaminants out. There was a time in which everybody was convinced that if there was any little bit of old mineral oil in the system and that mixed with the POE oil, that it was going to create this giant disaster. That was just what we believed. It's not true. But what does happen is, in past generations when people installed these systems that we're going back to, do you think they pulled a good vacuum on those systems? Do you think they did everything they were supposed to do? There's no way there's any copper shavings or dirt or anything inside those lines, right? Because they followed all the right practices. Of course not, it's ridiculous. So when we put our new system in, and now it's everything's all good, and now there's copper shavings and sludge and moisture and all that that's contained in that oil, in that trap there, we want to make sure that we get all that out. And that's why that's the main reason why we use the pipe wiper or the Hilmor line set cleaner, is to get all of that out. It's not because we're so worried about getting a little bit of mineral oil in the POE. That's not the thing, even though it's not great anyway. In terms of our practices, we make sure we don't get anything in the lines. We make sure that if we know that, say you are doing you're deburring or reaming your copper, and you know that maybe some shavings fell in there, we're supposed to tilt it down when we ream or deburr, but let's say for some reason something got in there, then that's when you go on the other side, you blow it out, blow a pig through there to make sure that, and that is the technical name for those, by the way, those little slugs are actually called pigs. So pigs do fly on occasion.
Oh no, every time it will fly.
See what I did there? If you don't use your catch net. Yeah, make sure you don't leave a pig in the system. Yeah, good point. But once that's done, now we do want to make sure that we're pressurizing with nitrogen, that we're flowing nitrogen while we're brazing, that we're following all those practices. And again, flowing nitrogen while brazing is another one of those things that for past generations, everybody always acted like it was such a big deal, it was so hard, it was such a pain, but it isn't. Some guys will say, well, I don't have the proper regulator to do it, nobody got me that. What do you do in that case? Let's say you don't have the proper regulator, a nitrogen flow regulator, the one with the little floating ball, or the Western one that you actually set it to braze. What do you do instead if you need to flow nitrogen? You just twist it to a whisper.
Outside, just blowing the lines.
Just it's kind of, it's like, I'm exhaling carbon dioxide anyway. Yeah, no, don't do that. Yeah, so you just adjust the T-handle till you just get a whisper. You can barely hear it. That's all you're doing. And even just as important, if not more important than that, is to go ahead and do that purge initially so that you get that initial oxygen out of there that got into the system when you were doing your work. Again, you're not going to leave the system open that long anyway. In general, you make sure you do keep it closed. If you're ever working in a case where it's raining, don't start doing pipe work until you make sure that it's completely covered. Like, don't do I can get it real quick. Again, any liquid water that gets in the system is like 1,000 times worse than water vapor. Most of what we're dealing with when we're talking about getting moisture in the system is just moisture from the air that gets in the system. If a drop of liquid water gets in that system, it can create a lot of havoc, especially with the PVE or POE oil system, so which is what we work on today. So be really careful with any sort of liquid water, rainwater, whatever. So then you do your pressure test. Of the things that we can screw up the most often on an install with our procedures is just not being patient enough with your leak detection and pressure testing protocols. Because again, if you have a system that has even a small leak in it and you're pulling a vacuum, well, that whole time you're pulling a vacuum, you're pulling stuff in. And with the size hoses that we use and the pumps that we use and all that, you can pull a sub 500 micron vacuum with a leak. It's a falsehood that you can't. Now, it won't hold if you're doing your decay tests, but we know that sometimes you get impatient with that, and that's how you leave a leak. But if you're following the whole procedure where you're doing nitrogen pressurization, you're doing soap bubbles, you're letting the bubbles sit for a little bit and actually looking for those kind of microfoam like Bert talks about, and you're letting it stand for 20 minutes or so, 20 minutes plus, and actually checking on digital gauges to make sure it doesn't drop at all. Not like, well, it only dropped half a PSI. I think that's fine. No, it's not fine. There's a reason why it drops, right? And it may be your hoses, it may be something, and many times it's something in your rig that's connected to it, but you need to find that anyway, otherwise you're always going to be chasing it, which is also why I like using probes, because with probes you have less that can leak. It makes it a little easier on that front. Anyway, so you do all those procedures. That's going to really prevent getting things into the system. Like we talked about before, reaming and deburring is actually more important than we probably generally give it credit for, because if you don't deburr your copper, even when you connect to the system, it does create turbulence there. And over time, that turbulence can actually create leaks. This is kind of especially if the braze joint isn't really good. because now you do have more friction right there in that area. So when you take you're making this connection here, and say you only do a cap on this or you don't seal that very well, over time, if you leave this burr here, there's this eddy current that's created there, and that can actually end up revealing a leak. Again, if you do your bracing properly, that's not going to be the issue. But we should be taking that and deburring it. A little trick that Joe Shearer talks about, and is probably for most of us just as good, is to just take needle nose pliers and put those in there and kind of just, again, if you're not making a flare joint, you're not worried about having a perfect edge, you're just trying to get that little burr kind of smushed back. That's going to be less risky than taking a deburring tool and actually cutting it off, because now that burrs, can go into the system. Whereas if you're just using needle nose and kind of smashing it back, it's not going to be as likely to do that. That's basically it. Just make sure that you're not leaving any of that stuff in the system. Make sure, obviously, you're discharging all the nitrogen, pulling a good vacuum. You follow those procedures, you're going to be in really good shape. I do want to remind us that doing that pipe wiper, doing that that line set cleaner is really a very helpful thing. We've seen a lot fewer TXV failures, screens plug up, compressor issues since we've started doing that. So just make sure that we are doing that when we're using line sets, because it is very handy. Would you agree with that, Sam?
I would. One note on the deburring, remember not to have it at a downward angle. So you're deburring into the pipe, always try to get that angle on it. If it's simply not possible, then just,
what?
when you're deburring the actual copper, don't have the copper at a downward angle.
No, yeah.
There, right?
Wait.
Like he's saying.
He's saying you don't want it to fall in.
Burr down like
Yeah.
that.
Okay.
You don't want it like this.
Like this, right? It's like this, not like
Like
this.
he's saying, don't do this, don't do.
I mean, I kind of already said that exact thing, but Sam probably wasn't paying attention, so that's fine. But that's what I was saying about the needle nose. Is that if you do it with needle nose, you're not really removing the burr. You're just kind of smashing it back out, so that way you don't have that, because it's that sharp edge that's going in. That's what creates that eddy current on the other side. Which again, not only does that potentially reveal leaks, but it also or reveal bad braze joints, but it also creates additional friction. That does, how much of a difference does it really make? Probably next to nothing, but it is a best practice to get used to, especially if you're doing like a job that does have a lot of braze joints. So commercial jobs where you've got long line sets, if you don't ream all those down the line, you're adding a lot of friction over that length of copper. And it's also a place that you can catch oil and contaminants and everything else. So.
And the last thing, being able to trust your equipment is pretty big. So, maintaining it, changing the oil, keeping your core removers, everything in a nice, dry, fitted case, keeping as much moisture as possible, attaching your hose that you use at 2 points so it's not going to wave it in the air. Because when you get in those situations where your pressure is dropping, you're not able to pull a vacuum, you don't want to be sitting there thinking, is it my equipment or is it the system, right? So having quality, kept up, maintained equipment is big. Just keep that in mind, both with your recovery machine, your vacuum pump, anything like that is going to be helpful.
Yeah, that's where, using this, getting comfortable with your set of tools. This is something that Craig from AC Service Tech, some of you have probably seen his YouTube channel, he talks about, and I think it's really smart. Like, get a set of tools that work really well for you, to where you understand them really well. You have a case, like you said, you have them set in a particular spot in your truck, and then just stick with that. Like, once you've got something that's working for you, just stick with that. When it breaks or it needs maintenance, then get it fixed or replace it with the same thing. Don't keep rethinking everything all the time. Once you get a system that works really well, just stick with it. And we've already got most of these processes really, down to a science. Like we talked about micron gauges, testing your pump on a regular basis, changing the oil on a regular basis. Are you going to put the micron gauge just on your pump every single time you do an install? It'd be good if you did, but even if you don't, do it periodically. So once a week, just hook the micron gauge right to your pump and just see what it pulls to with just the pump and the gauge. It should pull well below 100 microns by itself. If it doesn't, then that means the pump's not performing, probably is oil. So go ahead and do an oil change on it, that kind of thing. So just those simple things will make everything a lot easier. It's just like, sharpening your axe. You can keep hacking away with a dull axe, but why are you guys chopping trees down with axes anyway? That's not part of our job, Don't use axes on the job. You don't need to sharpen them. Right. Pack a chainsaw. Yeah, uh-huh. Yeah, don't do the next thing.
Trim the hedge.
Yeah. Okay. All right, I think we've covered this very well. All right, thanks guys.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.